Hey guys, what's going on? I miss you guys a whole lot. I miss starting my days off with all of your guys' bright faces, but um, nothing any of us can do about it. Um, I hope you guys are all healthy. I hope you're finding a way to stay busy and aren't getting sick of being cramped up in your house, but I know how easy that's become. Um, Anyways, here's our first lesson. Um, just kind of to go over a couple things. We were going to cover chapter 11, chapter 6, and then chapter 12. We are not going to do that this semester. We're cutting way back. We've gone through and we've cut a whole bunch of things. So we're going to cover chapter 11, which should be a pretty easy chapter. It's essentially surface area and volume, which is something you guys should be accustomed to, along with a few other things. And then we're going to go to chapter 6, which is, I don't know, something about triangles, but we're not going to do 12 at all. And we probably won't get through all of chapter 6. We'll just kind of wait and see. If we do, great. If we don't, that's all right too. I hope this is finding you well. Bear with me. I'm on someone else's whiteboard. My classroom's not set up to do this, so I'm in someone else's whiteboard, and I don't like it at all. I'm not used to it, so bear with me. Hopefully, it'll get better as these lessons go. Today, we're going to cover section 11.1, circumference and arc length. A lot of this you guys probably already know, but there's probably going to be some that you don't know as well. So let's get started. All right. As always, we need to start out with vocab. That hadn't gone away. Let's move that out of here. All right. So a circle, we just finished our circle chapter. You guys should know what a circle is, but remember, it's the set of all points in a plane that are equidistant. Sorry, I told you I suck at pen. From a fixed point, and that fixed point is the center. Okay, so every point around it is equidistant. All radiuses or radii are the same distance from the center. Diameter, essentially it's two radii put together. So a diameter is a chord. Remember back to last chapter's vocabulary. A chord is a circle that both endpoints are on the circle, but a diameter is specific because it contains the center of the circle. Most of you guys know a diameter is 2 times the radius. A radius, hopefully you know as well, a segment with one endpoint as the center of the circle. And the other endpoint is on the outside or on the boundary on the outside of the circle. Okay, circumference. Think of circumference as like the perimeter of the circle. It's going to be the distance all the way around, but only one time around the circle. Arc length would just be a part or a piece of the circumference. So maybe we don't want to go all the way around the circle. Maybe we only want to go halfway. Or maybe we want to go a third of the way. We would be finding an arc length, not a circumference. Radians. I know you guys remember from our trig chapter when I said make sure you're in degree mode, not radian mode. Radian is just a unit of measure for angles. We won't use it a whole lot. We're going to learn how to convert now. Algebra 2, you'll use a little bit more. And then after Algebra 2, pre-calc and on, that's all you'll use. Just think a radian is just another way to measure angles other than degrees. So like temperature, you have or Fahrenheit, Celsius, and Kelvin. They all measure temperature. It's just in a different form, a different unit. Same thing as radians and degrees. Pi, something you guys may not know. Not what you eat pie. It's the ratio of the circumference to the diameter of any circle. So in order to find pi is simply circumference divided by diameter of any circle. All right, let's do some examples. Most of you already know this. Circumference, there's kind of two different formulas floating around. So circumference can be pi times diameter, or circumference can be 2 pi times the radius. I tend to gravitate to the 2 pi r. It doesn't matter which one you use. Just remember that one diameter is 2 times the radius. So this and this, they're essentially the same equation. Just one's written in terms of a diameter, the other's in radius. All right, example 1. So we want to find the circumference of a circle with the radius of 9 centimeters. So once again, the circumference is 2 pi r. If you want to use pi d, that's fine. I just like to use 2 pi r better. All right, so we want to find the circumference when the radius is 9. So our r is going to be 9. So this is just going to be 2 pi times r is 9. If we simplify this, that would be 18 pi. I'm just going to leave it as that. If you guys want to put 18 times pi in your calculator, get a decimal, that's fine too. So part B, we want to find the radius of a circle where the circumference is 26 meters. We still use the same equation. So C equals 2 pi r, but this is what we're going to put in for our C. So 26 equals 2 pi r. Okay, now I want r by itself because I want to find the radius. So I'm going to divide by 2 pi. Divide by 2 pi. Now, guys, make sure to take note. Anytime you have two things in the denominator, so here we have a 2 and we have a pi, if you want to change this to a decimal, you must put this in parentheses. Otherwise, your calculator will read it as 26 divided by 2, and then that whole thing times pi. Okay, we want it divided by the 2 and the pi, so make sure you put this in parentheses. So 26 over 2 pi, kind of ran out of room over there. You can reduce this. This is just 13 over 1 as 13 over pi. And then once again, if you want, you can put that in your calculator and get a decimal. Hopefully these are reviewed for you guys and not too difficult. All right, let's go to our next example. Well, first, let's talk about arc length. Okay, so arc length, if we wanted to find the circumference, we would find all the way around the circle. Okay, if we want to find an arc length, that's just a piece of that. So here the arc length is AB. We just want to find that B. So you can use either one of these equations. I typically write my own. I say, whoo, sorry, this board, I don't like it. We can say that the arc length equals the proportion times the circumference. Okay, so for example, if I wanted the arc length of 1/4 of it, it would be arc length equals 1/4 would be the proportion and then the entire circumference, which should make sense because that's just circumference divided by 4. Okay, if I break this down a little bit more, so this is arc length equals, now my proportion I can always find is my central angle over 360 times my circumference is always going to be 2 pi r. Okay, so this is what I'll normally use, unless I want to try to find circumference or something, then I'll just leave 2 pi r as c. Hopefully this will make more sense after we do the next example. Come on. There we go. All right. So here, I want to find the arc length of AB. Now, some of you are thinking, well, do we want this AB or do we want this AB? So remember back to when we did the circle chapter? When we talked about arcs, we always wanted the shortest distance unless it specified otherwise. So we want the yellow AB. Okay, so arc length, I don't know, I'm just going to put as L for length. Arc length equals, well, the proportion, and remember the proportion is the central angle, which is 60, over 360, because there's a total of 360 degrees all the way around, so that's the proportion, times the circumference, which is 2 pi, and my radius is 8. Okay, so if I just simplify this just a tad bit, I would have L equals 60 over 360 is 1/6 times 16 pi. And if I reduce it a little bit more, I have L equals 16 pi over 6. And then here my 16 over 6 breaks down. So L equals, what is that? 8 over 3? 8 pi over 3. And that would be centimeters. Or you can put 8 pi over 3 in your calculator and get a decimal. And that would be the length of A to B or B to A. Now, don't confuse arc length with arc measure, because the measure of arc AB is 60 degrees. It's the same as the central angle. But the length is how long it is. So if we measured it like with a tape measure or something, it'd be 8 pi over 3. All right, so let's do B now. We want to find the circumference of circle Z. Here we have the arc length. This here is my arc length. So I'm going to use the same formula. So my arc length, so 4.19, is equal to, my proportion is, central angle is 40, so 40 over 360 times, here I need to find my circumference, so rather than finding my radius, I'm just going to keep it as C, so times C. If you want, you can put 2 pi r like we did over on the other example. After you get your radius, you can plug it in to find the circumference, but that's just unnecessary work. All right, so let's reduce this a little. So I have 4.19 equals 40 over 360 is 1/9 times C. So to get C by itself, let's multiply by 9 on both sides. That goes away, so 9 times 4.19 equals C. And if I put that into my calculator, I got C is roughly 37.1, and that would be in inches. All right, last but not least, find the measure of arc RS. Once again, we want the shortest arc, so we want this arc. This here is our arc length, so 44 equals, guys, here we don't know what our central angle is, okay? But we know that our central angle is right here, and it's going to be the same as the measure of RS, okay? So it's going to be central angle, so I'm just going to call it X over 360 times my circumference, which is 2 pi times 15.28. All right, so now let's do some math. So this is just 44 equals, X times 2 pi times 15.28 over 360. All I did is I merged them together. All right, if I put, we won't even do that. So let's multiply both sides by 360. Oh, come on, don't crash on me. So times 360 here, times 360 over here, those go away. So I got 15,840 equals 2 pi times 15.28 times X. Well, guys, I'm just solving for X, so I want to just divide by 2 pi times 15.28. If I do it on the right, I have to do it on the left. So 2 pi times 15.28. Once again, remember in your calculator, when you do this all's wrapped in parentheses. Put that in my calculator, I get that roughly 165 equals x. So that's my central angle. So this is 165 degrees, and we learned last chapter that the central angle is the same as the arc. So the measure of RS is also 165 degrees. It's the same formula, just plug in what you know, find what you don't. All right, let's do a couple word problems. All right, so here we have a tire, guys. And we know from the hubcap to the end of the tread is 5.5. The length across the hubcap is 15, and then 5.5 here on bottom. So if I added all these up, this whole thing here is 26. So if I had the circle, that would mean the diameter of this is 26, which means the radius is 13. All right, so it says the dimension of the car tires are shown. To the nearest foot, how far does the tire travel when it makes 15 revolutions? So for those of you who don't know, one revolution would be once all the way around. So if I started here, I'd go around, and when I got to here, that'd be one revolution. So really, one revolution is the same thing as one circumference. CIRC, period. One revolution is the same as one circumference. So first thing I'm going to do, let's find one circumference, which would be one revolution. So C equals 2 pi R, which is 13, which is 26 pi. Guys, I'm eventually going to have to convert this to feet, so I'm going to go ahead and put this into my calculator. And when I do, I get their circumference is roughly 81.7 inches. All right, so that's for one revolution. I want it for 15 revolutions. So I'm not going around once, I'm going around 15 times. So I'm just going to take this, 81.7, I'm going around 15 times, so I'm just going to multiply it. And when I do, I get roughly 1,225 inches approximately. But notice it says to the nearest foot. So to go from inches to feet, just divide this by 12. I get roughly 102. That's a 2 feet. All right. Come on. My computer's getting slower and slower. I'm praying it's not going to crash on me. All right, here we go. Another word problem, and then we'll do some degrees to radians conversion, and then we'll be done. All right, so a word problem. A runner's going to run around this track shown here. Okay, so we know this is 84.39 on the bottom, which means it's 84 point, oh, come on, 84. My pen's wigging out on me, guys. And my screen's getting slower and slower. There we go. All right, let's try this again. 84, there we go, 0.39, maybe. That's a 3. Something like that. All right, so now what I need to do is I need to find this here, and I need to find this here. All right, let's do this part on the left first. So let's do this first. So I want the arc length of that to the left. Well, my radius is 36.8. So my circumference is going to equal, or not my circumference, my arc length is going to equel. Well, guys, Isn't this 180 degrees? So 180 over 360 times 2 pi times r, which is 36.8. Okay, it's long and it's scary looking, but when I plug it into the calculator, guys, I get 115.6 meters. So 115.6, roughly, give or take. All right, now I want to do this side. Notice the radius over here is slightly different. So I want to find my arc length over here. Well, guys, this is still half of it, so 180 degrees. So 180 over 360 times my circumference, which is 2 pi. My radius is 44.02. Okay, when I put that into my calculator, I get roughly 138.3, and that'd be meters. And then all I have to do, the runner's going one time around, is add these numbers up, this plus this, plus this, plus this, all the way around, and unless my calculator's wrong, okay, maybe unless I put it in wrong, the answer would be 422.7 meters, give or take, depending on how you round it. All right, come on. Ooh, that's not what I want. There we go. One more, don't die on me. All right, so here's converting between degrees and radians. Okay, so to go from degrees to radians, we're going to multiply it by pi over 180 degrees. And when we do this, we're going to leave pi in our answer. Okay, we're not going to put pi into our calculator. We're going to simplify the fraction and leave pi in. You'll see what I mean here in a minute. Okay, now when we go from radians to degrees, we're going to multiply. All we're going to do is flip it, 180 over pi. All right, so convert 45 to radians. So we're going from degrees to radians, which is right here. So we're going to multiply it by pi over 180. So 45 times pi over 180. Well, guys, think of 45 as 45 over 1. This is the same thing as 45 pi over 180. And then if I look here, 45 over 180 reduces to, what, 1/4? So 1 pi over 4, or just pi over 4. And you don't have to put radians after it because it's kind of understood that if you have a pi in it, you're talking about radians. All right, now let's flip. Now we're going to convert 4 pi over 3 to degrees. So 4 pi over 3. So now we're going from radians to degrees. So we're going to use this. So we're going to multiply it by 180 over pi. And notice when I do that, the pi and the pi cancel each other out. So we're just left with 4 times 180. Woo! 4 times 180 over 3, which is 240. Hold on, let me check. You guys know how good my mental math is. Yes, 240 degrees. 240 degrees. And then here's our final answer. All right, that's all that I have for this lesson. Your homework is on big ideas. Remember, all assigned homework for the week. Homework is due at midnight on Thursday night, and then I will assign your next week's lessons on that next Friday. Please let me know if you have any questions, guys. I don't want you to feel like you're at home alone and you don't have anywhere to go. So if you have questions, please reach out via email, and I will get back to you as soon as I can. Hope you have a good one.